Hey everybody, this is Larry. This is day 22 of Advent of Code. Hope you enjoyed the last couple of days where I pulled out 5-hour videos of me struggling. But yeah, today hopefully struggling a little less, or at least that hope. 40 seconds to go. This is live, so no timer, no nothing, just leaderboard or not. Um, you want the explanation? It's going to be toward the end, maybe the last couple of minutes, and hopefully this is not the last couple of minutes of another 10-hour video. But yeah, 20 seconds. So definitely definitions, with explanations and stuff like that will be there. I am back in New York, but I am still jet lagged as yeah, I've been sleeping during the day too much and etc. Just way off. So we'll see how it goes. I was so good in Taipei, but here, not so much. 5 seconds to go, so let's go. Go, 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 go. Yeah. All right, well. Let's get numbers. What if these are the same? Am I misreading this? I don't understand. There's so much reading. Oh wait, I misunderstood this one. This is just the end. Okay, so each of these are one cube or one thing. Okay, I misunderstood this one, but okay, fine. This is gonna be annoying to implement actually, but okay, fine. Oh, So like a 3D Tetris thing. This is not an easy one. This is not going to be an easy one at all. Well, maybe the first part should be okay. Maybe. Okay. Well. I guess part one should be okay, but maybe. Kind of. Yeah, not leaderboarding today, but okay, fine. So basically, no one has done it yet. Okay, so it's not just me. Okay, so I mean it's just simulation, I think, but it's not an easy simulation. Thousand is a lot of cubes though. Best way to do 3-dimensional intersection. none of these there's definitely a couple. Okay. Really want it? Okay, fine. And now what do I do in the sections again? this isn't right. This is not readable. But these may be equal, but yeah. Okay, we could actually do a little bit better on intersection. I mean, these are supposed to be equals. What? Is that true? I guess I should do an input. I guess I didn't need to comment that out, but okay. No, this isn't right. Can I remove this as if? Okay, so no, this isn't right. So it's not just that, because no, it's just that. If only has one parent, then 7 is a little weird. Five, okay. YOLO. I don't know if this is right, but nope. I mean, it works for the original one. So, I mean, it has the right answer, but I don't know if this is actually right. Just figure YOLO. I thought I had it though. Parents. So these two are no good. Did I? You cannot disintegrate 0 or 5. Yeah. Three is 1 and 2. I mean, okay, I think my code is right for the example, but you know, part 2 is a little bit trickier. All right, so people have gotten it. What am I simulating? Wow. I thought I had it, but maybe there's a typo or something. Oh, I didn't do this correctly because we're only counting that, but we didn't count. I didn't count the extension because I'm assuming 1-dimensional cubes for some reason. Why didn't I do it this way? Premature optimization. Also, this is wrong. Copy and paste error. Huh. That's actually pretty bad, but okay. That's why I did the optimization, but 471. I don't know if this is right, but alright. Better than whatever, even though it took slow. This is actually easy the way that we did it, but wish I did part one in a dumber way. Optimization. Alright, Larry, shut up and focus. Okay, this is easy, Larry, focus. You got this. Go to parents, right? Yeah, I didn't copy over. Oh, well. 15, which is not right. -1 for the x, but still 15 is not right. Why? Why am I returning 15? How do you get 15 now? Oh, because it branches some of these things. Because it's not a tree. Yeah, which is n square. So that's not. One day I'll do it, make it so that it caches the first time or something. But oh no, 471 is the right answer, right? Okay. Did I misunderstand this? Yeah, I mean, that seems right. So this... Oh, because... No, it doesn't make sense. Why? Man, today is just not my day, even though this is actually a poem that I really should have gotten. Am I misunderstanding this? I mean, the first part is right, so it shouldn't... How can the first part be right and the second part not be right? No chance of... Yep, missed the leaderboard. And today is just not my day. What is my error? I'm trying to visualize things in my head, but I don't really get it. What can I be doing wrong? I thought this was pretty open and shut. I don't know. I guess there's a bug somewhere, but no, I don't think. Am I misunderstanding this? It's slightly faster, but it's slightly faster with one solution. And all the work is on the part one anyway. Is this one? Should be okay. Man, at least yesterday I had an idea of an attack, but now I don't. It works for the input for the test case. How can my code be right for part one and not for part two? Oh. Wow, I don't get it. I mean, my intersection thing's lucky. Like if I did this, does that change the answer? Change it to 0 actually even, but No, so I think this is right, or at least be even more wrong. I don't get it. This is supposed to be like my you know, like part one is but part two, this part is supposed to be, or the depth of search. I don't count anything more than once. I was set. It is frustrating. Get it. This is gonna be. This isn't gonna be the same thing as yesterday, where I don't know, put in the same thing and it gets. Or already, the right answer was in me all along. There's no other way to write this, is there? I mean, the code is right, I think, but maybe my understanding is wrong. No, if part one is right, unless I got really lucky and like two things canceled out or something. Part one is right. I don't get how part two. The pound is. Man, this is not my year, I guess. it's not even a grind. I just don't have any understanding of how to debug this. Assuming part 1 is right. Part 1 might not be, but I don't even know how to debug this because I don't know what is. This is so elementary. I don't. Unless I have a typo somewhere or something like this. What? Oh, because of this. Yeah, that's definitely not right. I didn't think that was right, but I had no idea. I have no idea. Am I missing a case? This is. Oh, maybe I am. No. No, you thought about that. Oh, wait. Oh, wait. Oh, wait. Oh, wait. Oh, wait. Okay, there is a case, maybe. Wait, is it? No, there is a case. I see. I think I. How do I take care of it? Basically. Oh yeah, okay. I see. I see why this mine as well. If I have something like, I try to figure it out, like this. We cannot remove A, but we cannot also just go up blindly, right? Okay, I got this. I got this. Because E is a children of. Okay, I see. I see. Wow, that is pretty bad for me though. In terms of, I don't know. I'm just missing some. Okay, so then now children, you only go to the children if. Okay. Yeah, keep this. Okay, I see. I see. So then now, wow, how did I miss this? I keep thinking of a tree. That's why. Okay. So then basically for you children, f of y add x, right? And if length of f of y is equal to length of parents of y, okay. All right, I see. Oh no. I mean, it was a little bit YOLO, but maybe I could have tested it. Why though? Tell me why. I don't need to do this. Oh, because we don't add this until all the things are gone. Okay, fine. No. No, this should be right. I mean, I don't think this is any different. Is there another case? That's the number we tested, right? So that's not right. So that should be. So basically, this is saying, okay, for each children, the children will go, okay, one of my parents is gone. If all my parents are gone, just in case, but I don't think so. Yeah, I mean, okay. I didn't think that would change anyway. I mean, it would mean that I have an issue of something else. But, is it undercounting because of some order of operation? Yeah. You do some. And now look at its children. One of the support is gone, and when all the supports are gone, then it is done, right? I don't think this changes anything though. Why? How is this a number? Do I count the same number? No, I don't think so. Okay, well, I mean, what was the one with the Death First Search one? Yeah, 7:55. I definitely should have gone part 2 quicker, but I had some misunderstanding of the problems, to be honest. Yeah, 2:22 for the first one, 7:55 for the part 2 is kind of. And prematurely optimizing for part 1. I didn't even need to optimize for the way that I did anyway. Would have gone on the leaderboard, I think, because that cost me like 10 minutes. Part 2, I don't know. Do I double count something? Is that why? How can that even double count? I mean, yeah. I'm curious. Yeah. I shouldn't have erased my Death First Search, but it was very easy, right? I'm trying to figure out like why this wouldn't work. Okay, I know why it didn't work, because I did the resetting of this thing I didn't reset this. I needed to. Is that why, Larry? It may be that this actually works, but I just was dumb. Well, I mean, yeah. Takes 10 seconds to go to part 2, which is a little bit annoying for debugging, but I am dumb. I forgot to I put this outside and then I just didn't reset it, and when you don't reset it, I guess it was adding a lot of stuff. I mean, I was on the leaderboard by then, but so it's okay, I think. But I definitely spent like half an hour on it or something, right? No. That's not true. It was more, less than that. I spent some time debugging this if statement because I was not thinking about this case. This case. Okay. Part 1 I should have gone. I prematurely optimized for part 1. and this has been a rough couple of days for leaderboarding. The problems are a little bit harder, but and maybe I am a little bit jet lagged, but oh okay. Let's go over part 1 and part 2. Can I wait? Before I go over it, yeah, sorry, I was chatting on Discord, kind of going over this. I think we can do an optimization here. I think intersect. So basically, you want if they intersect on everything not the x, right? If intersect, okay. Let's rewrite this a little bit. Actually, before I do that, let me save it down somewhere. I really should put these in a repository. Part 1 and part 2 actually are the same part, so I don't, well, like not the same, but you know, I just have to add extra components to it, so it's not that thing. But let's do. Okay, and then now let's see if we can optimize. I basically what I did for me, part 1 is oh, someone told me that Nick did well, did he? Oh wow, I mean, well done, both parts. Been killing it this year. I don't know. I don't think he watches this, but still, props. But yeah, but for me, I just simulate one brick at a time. Which, yeah, I don't know. Maybe this was premature. I don't know. I was trying to just basically lower the number of search spaces, but I guess it is not really necessary per se. So find 0 to true. Okay, intersect. How do I mean, I want to rewrite it so that it just takes the max z components, but yeah, so that means that this will intersect with some stuff, but then you have to calculate the parents and stuff, so maybe we'll just do it twice. And then we don't need this. All these hacks. Keep those for now. So it's equal to max and C, or quick choose 5, which is yeah. So NC is the last. Maybe just +1. Okay, so then now brick of 2 would be equal to NZ. Right, DZ is equal to brick of okay, right, and then now to get the pounds again, I mean, basically I did stuff that's even worse than n square, but Maybe I'll just do this with -1. And then now add it back. Is that the right answer? I don't remember. It's roughly right. Okay, so it is actually exactly right. So yeah, so then after that it's just, so n square is fast enough, but I was doing even lazier than n square. Yeah, let's go over the code now. I mean, I think this is fast enough, right? This is, I think I tried to be a little bit too clever with the optimization because I was trying, and I forgot about the z-axis, but I was trying to make it so that you don't look at, well, I just tried to make it not n square. I'm a silly man today. Okay, yeah, let's go with, sorry friends, I keep saying that and I keep delaying it, but yeah. Okay, so let's go with, I mean, I put everything in one code, so hopefully it makes sense. But yeah, so let me also just bring up, I guess I can go over the code and paintbrush. All right, let's go over the understanding part first. I think this one is actually not that hard now that I rethink about it. But I think I just kind of, I think a lot of people just kind of want to make sure reading and stuff like that, because I actually kind of a little bit surprised about the submission times, to be honest. Like, as in, I thought that it would be faster, or like other people, not me. Well, I was hoping that would be faster as well, but I thought, now knowing what I know, then it should not be. But yeah, but basically the idea here for me is, well, first of all, I sort by the z-axis so that you're going from the bottom up, right? Like the things, they're going to just go 4 straight down, and basically you're playing Tetris one at a time. So what I do is that I drop them all straight down, but when you drop them straight down, if you don't do it in order, they're going to, like, for example, if this brick is here, this other brick falls on it, and then you move this brick afterwards, then, you know, you still have to move this back down again. So but yeah, so you have to do them in the right order. But if you sort by Y, then there's no way that, like, if some brick is on top of another brick, there's no way that they share a Y, right? Or a Z axis, sorry. I've been saying Y a lot, but because this is 3-dimensional, like, yeah, so there's no way they share a Z axis, right? So when you sort them, then you'll do them in that order of bottom to up. So okay, so then now we're going to remove one dimension, you know, just so that it's a little bit easier to draw. I mean, I know that they tried it a little bit on the thing as well for that reason. But yeah, but basically the idea then is just now settled all of them because they only drop down. There's no, and I think I try to be too clever with this one. during the contest because I think I'm still stuck on Tetris things. So I was just dropping them one step at a time, which for Tetris is probably reasonable. But here, there's every shape is convex, right? So so you don't have to worry about stuff like that because they're convex, so they don't have to. So there's no stuff about like hanging up, and then everything is just rectilinear, right? So basically, the idea here is that okay, so now you have a. Let me make sure that everyone on screen. You just have a bunch of bricks, and then honestly, right, and then now you're just going down, and of course I'm skipping one dimension, but you can visualize it in 2 dimensions. We'll go over the code part in a sec, so you can kind of do the actual math with 3 dimension, but that's the idea, and I didn't even draw enough to intersect. But yeah, basically just go. Well, they fall down, but you actually parse them, bottom up, right? As we said, we saw it. So then here, maybe, how do I draw this like a water? So then now this settles down to here, and then so forth, right? Right? And then, yeah, so that's basically the idea. And the thing is that an implementation, I mean, this is the idea. The idea is easy, maybe even, I mean, looking at this problem, that's all they ask you to do. So it's not a difficult idea. The tricky part is the implementation. And the implementation part, the tricky part is going to be a couple of things. One is, that's why we do it bottom up, is that when you look at all the things that are on the bottom, they already settled. But that means that you also don't look at intersections with polygons up, right? So the tricky case is kind of, well, one is try to figure out what you intersect with in 3 dimensions, which we'll go over it in code a little bit. But the idea is also like, you can also intersect, but not, there's a gap, right? So you have to handle that as well in a clean way. And obviously the core of this problem is that if you have one brick with 2 supports, then you have to kind of like, make sure that you kind of attribute the right things. So that will go over in code, because I think the visualization is just, I think the sorting part is the important part of this to make the code work. But we'll go over the code. Hang on, let me go window. Yeah. So we have some intersection problems. So intersects only x and y, and this is check if intersects x, y, and z, right? Or is that okay? So as we said, we first sort by the z direction, which is the index is a little bit weird. These 2 functions hopefully make sense. It's just very basic intersection of x and y, though I say that, but I've been getting it wrong a lot lately, so I don't know. But basically, this is just saying that if you have 2, so, well, this is the 2-dimensional version, right? So you can almost say that two rectangles intersect if they intersect in both 1D dimension. So let's reduce it to a line. So if you have a line, basically they intersect if you have this like thing, and this happens when you draw out all the if statements, though you could actually do more if statements if you want, but basically when it comes down to it, this is the 1D1 for x, this is the 1D1 for y, and this is the 1D1 for z, and that's basically how you do intersections. I'm not going to draw it out today, but hopefully that makes sense, and you can kind of do it offline. Okay, after that, I had this done thing, but it was for that optimization that didn't work. But okay, yeah, so now we do an n square thing. So for each brick, well, I tag it with an index just so that we can do stuff a little bit better. But yeah, and NC is the new Z, which is the highest point to fall on, and basically it is. And remember that the done 2 array, because I had a done 1, but then I rewrote it. But yeah, the done 2 array is just saying for all the bricks that are settled, right? So that means that all the bricks that are going to be below this brick or adjacent, but if it's adjacent, then it won't intersect anyway. And you can also do this in a more smarter way if you do some like, you know, quad tree or a lot of exotic data structures. I call them exotic anyway. But for the purpose of this, n squared is fast enough. My n is like 1300. So yeah. So I do, if this intersects on x and y, that means that it's going to fall on it, maybe, right? And when I say maybe, because it would fall on it if it's not blocked by any other blocks, right? It may be like held up by other blocks. In that case, that's a little bit different. So yeah. And in that case, we look at the high part of the brick that you're intersecting, because it has the low part and the high part. If you look at the high part, you add 1 to get to the next z-axis, and basically you just kind of max off all of those things, right? So if it intersects of 5 cubes or 5 rectangles or whatever they are, rectangular prisms, if you will, then you take the one that's the highest because that's the one supporting it in this problem. Okay, and then after that, I just kind of this is just math to set it to nz. The new z. I'll explain the -1 in a sec, but you said the new z, and then you make sure that the d is the high and the lows are consistent and the same. And then here we do it again. This time now we're trying to figure out all the parents, right? All the things that it's actually touching and not just intersecting. So that means that it has to touch on the z-axis itself, and that's why I have a -1. Is that right now it's touching it on this edge. Maybe you could rewrote it so that it's like maybe we could rewrote this part so that it's -1 or something. But I was just like, this is easier to read and understand and debug. So I just so basically the idea is that if it's sitting on it, technically it's not intersecting, right? So if I move it down by 1, then it'll be intersecting. So then now we try to figure out all the other bricks that it is intersecting, and if it is intersecting, then one is that I said, okay, for me, my parent is going to be this brick. And for every brick that intersects, it sets up all my parents that way. And then also the other thing is just set up the reverse relationship. The children of those bricks will have me. Setting up a tree. Just setting up a relationship thing. And then now we move it back up 1 because now we calculate in the seconds, we move it back up, and then we calculate as done. That's pretty much the idea for part 1. And I think this other thing is part 1. So part 1 is just basically asking, okay, if and this is just like understanding it, right? And it took me a while too, so I'm not like pausing for dramatic effect. Or maybe I am. Dun dun dun. But no. For this one, basically, for certain brick, for every brick, it would fall if it loses the support of one other, or its parents, right? But so if a brick has only one parent, then you cannot remove that parent. So that's basically what this thing is saying. So if this brick only has one parent, then you cannot remove that brick because then now this one would fall. So that brick is related to this one no matter what. And then now it adds that brick to no good, you cannot remove. So then, the ones that you can remove, I think that's part 1, right? The number of bricks that you can remove is just the number of bricks total minus the ones that you cannot remove. And then part 2, let me kind of bring back the drawing real quick. I actually just had to be honest, I understand part 2, but I think I don't know, in my mind I was a little bit off for this one. And what I mean by that is that I think I was thinking about it like a tree, and because I was thinking about like a tree, I did a couple of things wrong. And if you watch the live recording, it is just wrong in that way for that reason. But the idea here is that basically, you have a lot of things, and you have these things, right? And you have these supports, right? maybe, I don't know. Like I'm just drawing them in a weird way. And now that I look at it, now it looks like I'm drawing a cow or something, or like maybe an I don't know, a reindeer. Huh? Maybe reindeer's on my head. But in any case, right? So of course, as we already did part one. So and we already did the parents relationship, and I think I added children here actually, but I think that's true. Yeah. So now you have some parents children relationship, right? And then the idea here is that if you remove this, that and honestly, yeah, it turns out that I spent some time on this particular part because I thought I could memorize, but I was wrong about this, and I'll go over why in a sec. But I didn't even need to because, like I said, n squared is fast enough, as you see. But yeah, but basically the idea is that, okay, let's say, we have a list of things that we cannot remove by definition. I mean, you could check other stuff too, but by definition, for part one, if you cannot remove this, I guess maybe this, actually a lot of things, right? In that case, you just calculated the sum for all of them, and the sum of all of them is just going to be a reverse search. Basically, yeah, it's basically saying, okay, if I remove this, what would 4? I wrote this in 2 ways, breadth first search and depth first search, because one was that I missed this case actually because initially when I did depth first search as well, okay, that means that if this 4 is all its children and its descendants with 4, but that's not actually true, because for example, for this one that we're highlighting, if this 4 is this will 4, yes, but this does not 4, because this is supported by this as well, right? So that's the mistake that took me like 10-15 minutes to find. So yeah, but other than that, after that you could figure it out, and it becomes pretty straightforward, because for example, let's say you have an additional box, let's say you have this thing, in this case when you do one color, but that's fine, binding, but that's fine. But if you do this case, you do here, and then you do here, and then you do here, and then you do here, right? So there are a couple of ways you can do it, but that's basically just you could call it bookkeeping, in that you're just keeping track of where things are. And we'll go over the code. I actually wrote it both ways because I had a bug in my DFS one, and so I rewrote in BFS, and I was like, oh, huh. And it took me like 10 minutes to do. A lot of silly mistakes today, but I don't know. I'm blaming on the jet lag. But yeah, but for basically for which one that's no good, though you don't even need to, I don't think. Let me double check real quick. Right? Because the other ones would just return 0 is what I mean. Oh, well, okay, it changed during size because encoding this. Yeah, okay, fine. Maybe parents, I'll do parents. It should be the same, but maybe I'm missing some. I think this misses some stuff because not everything has a parent. Okay, fine. But yeah, basically for each one that we cannot remove, which is here, right? I did depth first search just for testing afterwards, and you probably saw it depending on how you jump around the clock. But yeah, but we'll go over the breadth first search one, and this is more straightforward. Basically, we keep track of all the things that we removed, right? And all the things that we removed for given children. So then here, when we remove X, we push it onto the queue to be removed, and then we remove this one, right? Oops. And count is just counting the number of things that we remove in total, and this is what we return, so not including the original block. But yeah, and then now for each of his children, we say, okay, this children now loses the support of me, right? So that's why f of y as now. You can also use a counter, I think, but I didn't want to risk it. I mean, it doesn't add that much more space. But then basically now, if all the things, if the number of things that we remove are its parents, we removed all of them, then now we queue up that one. So that's basically the idea. And this really should have been like a 2-minute thing. Did not happen to me though, for me. But yeah. And this is n squared because this is n and this is n-ish, right? So yeah. That's pretty much for part 2 in code. This is very standard breadth first search. But I mean, is it even web first search? It's just queue based for search. I think the way that I think about it is actually what you might call it. It's actually a topological sort. But I kind of did it in a really weird way. I didn't really think about it as a topological sort until later. So, but yeah, but that's what I like about topological sort is that you can actually rederive it without knowing topological sort per se. And the way that I think about it is that you remove any bricks that you can, which has no parent, and then you just keep on removing it. And the way that I did this is a little bit funky for topological sort because this doesn't need to be a set, but you can actually just rewrite this with a counter or something like this, right? In both sides, but I'm not gonna do that here. Yeah, these are the ideas. That's all I have. Let me know what you think. Yeah, stay good, stay healthy to good mental health. Let me show you the top one more time in case you want to see it all together. This is a lot of code though. So this is part 1 mostly. And this is part 2 mostly. With the bonus depth first search because I forgot. So my bug of the depth first search when I wrote it is that I forgot to reset the set. So I didn't. Very, very silly mistakes. But yeah. And then obviously I just put out the total in case that wasn't clear. That's all I have for this one. Let me know what you think. Stay good, stay healthy to good mental health. I'll see y'all later and take care. Bye bye.